For generations, there was a simple, brutal logic that most people accepted. Fewer whales means more fish. It seemed to make perfect sense. These colossal animals, some weighing more than a dozen elephants, consume metric tons of krill and small fish every single day. A single blue whale can eat up to 6 tons of krill in 24 hours. So, if you remove the whales, all that food is left for other fish, and by extension, for us. The great whaling fleets of the 20th century, armed with explosive harpoons and factory ships that could process a 60-foot whale in under an hour, operated on this assumption. They saw whales not as living beings in a complex system, but as rivals. And so they were eliminated with industrial ferocity. From the Southern Ocean to the North Atlantic, the seas ran red. Blue whale populations, once numbering in the hundreds of thousands, were slashed by as much as 98%. Some humpback whale populations were reduced to just a few hundred individuals. Overall, the biomass of whales, the total weight of all whales on Earth, is less than 25% of what it was before the slaughter began. And as the whales vanished, humanity waited for the promised boom, the explosion in fish stocks that was supposed to follow. But it never came. In fact, in the very places where whaling was most intense, the opposite happened. The brutal logic was wrong. Utterly, catastrophically wrong. We hadn't understood the system. We hadn't understood that by killing the whales, we weren't just removing a competitor. We were removing the gardeners, the engineers, the beating heart of the ocean's primary life support system. We were breaking the engine. To understand what we broke, you have to look past the awe-inspiring size of a whale. You have to look at what comes out of it. Yes, this is a story about whale waste. It might not be glamorous, but it is, without exaggeration, one of the most important ecological processes on the planet. Scientists have a name for it, the whale pump, and it works with a beautiful biological elegance. Most great whales are deep divers. A sperm whale, for example, will plunge thousands of feet into the cold, dark, crushing depths. Down there, in the midnight zone, it hunts for nutrient-rich prey like giant squid. These deep waters are where the ocean's riches are stored, a cold, dark pantry full of the essential elements for life. But there's a problem. Life, especially the kind that needs sunlight, can't access it down there. Phytoplankton, the microscopic marine plants that form the very foundation of life in the sea, are stuck in the sunlit surface layer. And often, this surface layer is a nutrient desert. This is where the whale becomes a biological elevator. The whale feeds at depth, loading its body with vital nutrients. But, like many mammals, whales tend to hold it in while under the intense pressure of a deep dive. Instead, they return to the surface to breathe and to defecate. When a whale does this, it releases what scientists call a fecal plume. It's a giant, nutrient-rich cloud that can spread for meters, and it is liquid gold for the ocean. It's a perfect vertical transport system, taking nutrients that were locked away in the deep, dark sea and pumping them right back into the sunlit zone where they're needed most. And the contents of that delivery are staggering. Analysis has found that the iron concentration in baleen whale feces can be up to 10 million times higher than the surrounding Antarctic seawater. It's not just iron. Their waste is also packed with nitrogen and phosphorus, the other cornerstones of life. And it's not just a vertical pump. Whales are also a conveyor belt. Many species, like humpbacks and grey whales, undertake some of the longest migrations on Earth. They travel from rich, high-latitude feeding grounds to nutrient-poor breeding grounds, and along the way, they continue to release these nutrient plumes, effectively transporting fertility across entire ocean basins. They are the circulatory system of the ocean. This is the whale pump, a constant, massive, biological engine that has been powering our oceans for millions of years. And for a century, we did everything in our power to shut it down. So, whales fertilize the ocean. It's a fascinating bit of biology, but why does it matter to us, here on dry land? The answer is that the consequences of this fertilization cascade through the entire planetary system. When that plume of nutrient-rich whale waste hits the sunlit upper layer of the ocean, it triggers an explosion of life. The primary beneficiaries are phytoplankton. These microscopic, single-celled plants are the grass of the sea. Fueled by the whale pump, phytoplankton blooms can be so vast they are visible from space. This bloom is the first link in a chain that supports almost everything. Phytoplankton are eaten by tiny animals called zooplankton, like krill. The krill are then eaten by small fish, squid, and seabirds. Those are eaten by bigger fish and seals, and at the top of this food pyramid, the whales themselves, gulping down the very krill populations that their own waste helped to create. It's a perfect, self-reinforcing feedback loop. More whales mean more fertilizer, which means more phytoplankton, which means more krill, which means more food for everyone, including the commercial fish species that feed billions of people. By breaking the pump, we were starving the entire system from the bottom up. But the importance of phytoplankton goes far beyond just being food. Through photosynthesis, they perform two services that are absolutely critical for our survival. First, they produce oxygen. It's estimated that phytoplankton in the ocean are responsible for at least 50% of the oxygen in our atmosphere. The true lungs of our planet are these invisible, floating forests of the sea. Second, phytoplankton absorb carbon dioxide, a lot of it. They pull an estimated 40% of all CO2 produced into the ocean. When these microscopic organisms die, their carbon-rich bodies sink into the deep ocean in a process known as the biological carbon pump. This locks carbon away in the abyss, where it can remain for thousands of years. Whales amplify this process. By fertilizing phytoplankton, they directly increase the amount of carbon being captured. But the whales themselves are also massive, swimming reservoirs of carbon. On average, a single great whale sequesters about 33 metric tons of CO2 in its body over its long life. When a whale dies of natural causes, its immense carcass sinks to the seafloor. This whale fall takes all that stored carbon with it, effectively removing it from the atmosphere for millennia. One study from 2010 estimated that before whaling, sinking whale carcasses removed at least 160,000 tons of carbon from the atmosphere each year. Economists at the IMF, looking at these combined effects, calculated that the value of an average great whale, based on its process of carbon storage potential alone, could be over $2 million, making the global whale population a trillion-dollar asset for the planet. The scale of the destruction is difficult to comprehend. The age of industrial whaling was not a hunt. It was a systematic, global eradication campaign. The invention of the steam-powered chaser boat and the grenade-tipped harpoon meant no whale was safe. In the 20th century alone, an estimated 2.9 million great whales were killed. Think about that number. Populations that had taken millions of years to evolve were decimated in just a few human generations. The Southern Ocean, once the world's richest feeding ground, became a slaughterhouse. The impact on the whale pump was catastrophic. As the whales were harvested, the supply of recycled iron and other nutrients they provided to the surface waters was cut off. This loss of fertilization had a domino effect. The theory that fewer whales means more krill was put to the ultimate test. It failed spectacularly. As whale numbers plummeted, so did krill. In the Southern Ocean, some research has suggested that krill populations may have crashed by as much as 80%. This seemed impossible, a paradox that baffled scientists for decades. But viewed through the lens of the whale pump, it makes perfect, tragic sense. The whales weren't just eating the krill, they were farming them. Their waste fed the phytoplankton, which fed the krill. By removing the whales, we removed the fertilizer. The phytoplankton blooms shrank and the krill starved. The entire ecosystem began to wither, and the carbon cycle felt the blow. One study estimated that pre-whaling whale populations stored an estimated 9 million more tons of carbon in their bodies alone than they do today. We broke the engine, and in doing so, we not only impoverished the seas, we weakened one of the planet's most important buffers against climate change. The silence of the oceans, once filled with the songs of millions of whales, was the sound of a planetary machine grinding to a halt. The story, however, does not end in total despair. In 1986, the International Whaling Commission enacted a global moratorium on commercial whaling. It was one of the most significant conservation victories of the 20th century, and slowly, painstakingly, it has begun to work. Some of the recovery stories are remarkable. Humpback whales in the western South Atlantic have rebounded to around 25,000, close to their pre-whaling numbers. In another extraordinary success story, the population of blue whales off the coast of California has recovered to about 97% of its pre-whaling level. These recoveries prove a vital point. If you stop killing whales and protect their habitats, they can come back. And as the whales return, so do the signs of a healthier ecosystem. The whale pump begins to work again. More whales mean more nutrient plumes, which means more phytoplankton. Scientists are now actively trying to quantify this effect, shifting from seeing whales as just charismatic megafauna to understanding them as critical components of the Earth's operating system. This is a profound shift in our thinking. For decades, our approach to climate change has been dominated by industrial solutions. But what if one of the most effective, nature-based solutions is simply to let nature do its job? Restoring whale populations isn't just about sentimentality. It is a direct investment in the planet's resilience. It's a strategy that can enhance carbon sequestration, boost fisheries, and restore biodiversity, all at the same time. It's a solution that doesn't require inventing a new technology, but rather remembering an old wisdom, that the great whales are not just passengers, but pilots. But this recovery is not guaranteed. It is fragile. And for the populations that are recovering, new threats have emerged that are just as deadly as the harpoon. Entanglement in fishing gear and collisions with ships are now the leading causes of death for many species, like the critically endangered North Atlantic right whale. The entire population of this species is estimated to be just 384 individuals as of 2024. They are being pushed towards extinction not by whaling, but by our everyday maritime activity. Noise pollution, plastic pollution, and the warming of the oceans are all adding unprecedented stress. The hopeful recovery we are seeing shows us what is possible. To turn that possibility into a global reality, the work of conservation has to evolve. It means creating and enforcing marine protected areas. It means implementing vessel speed restrictions in whale habitats. It means developing fishing gear that doesn't entangle these magnificent animals. It means fighting for a cleaner, quieter ocean. This is where we all come in. For too long, we have seen the ocean as a resource to be extracted, not a living system to be nurtured. The story of the whale pump teaches us that this view is not only wrong, it's self-destructive. Sharing this story is the first step. When people understand that living whales are worth infinitely more than dead ones, ecologically, economically, and ethically, the political will to protect them will follow. The story of the whales is a parable for our time. It's a story of ignorance, of the devastating consequences of seeing the natural world as a collection of disconnected parts. We thought whales were just a commodity. We were wrong. We thought we could break a fundamental piece of the planetary machine without consequence. We were profoundly, tragically wrong. But it is also a story of discovery and of hope. It reveals the astonishing interconnectedness of life on Earth. It shows us that a single species can have ramifications that ripple across the entire globe, from the deepest trenches to the atmosphere above. And it offers us a path forward, a path based on the simple, powerful act of restoration, of stepping back and allowing the planet's own elegant, time-tested systems to heal themselves. Bringing back the whales is a pragmatic, forward-looking strategy for a more stable and abundant future. It is a way to make our oceans more productive and our climate more stable. We didn't just kill whales, we broke the ocean's engine. Now we have the knowledge and a moral obligation to help restart it. Because we now understand that in saving the whales, we are, in the most literal sense, helping to save ourselves.